Last video on chapter 10 and the second video on inequalities. This one, as the title says, I'm looking at inequalities on number lines, and I'll also be going on to solve inequalities using algebraic methods. Hopefully the video won't take too long because we've looked at all those algebraic methods earlier in chapter 10. It's just looking at how we apply those when we've got an inequality, certain tricks you need to apply to certain questions, what the questions will ask you, and also that big warning I mentioned to you at the start of the first video on inequalities, the thing to look out for that is slightly different. So first of all, the number lines. Things to look out for is this dot here is not shaded in. It's a white dot compared to this one here, which is black, or it is coloured in. Could be blue if you've got a blue pen, who knows? Maybe even purple. What the heck? Go crazy. Anyway, this 4 is not included because it's got to be bigger than 4. So it could be 4.00000 going on forever 1, because that is bigger than 4, but 4 cannot be included, so we do not colour in the circle above it. Similarly, it's got to be less than 6, not equal to 6, so we don't colour in the dot above 6. But for this one here, we've got that x is less than or equal to. So we colour in this dot here because 4 is included, it can be equal to. Now because this one is not bounded by something else, we put an arrow on the end to show that it just goes on forever. You don't want to spend your whole exam drawing a very long line, you just put an arrow on the end there to show it goes on. Whereas this one, it's bounded at both ends, though both ends aren't included, it's bounded there, so we can just draw that line. Okay, so those will have a white or an empty dot, those will have a coloured in dot, whichever colour pen you have. So I've got here some examples of solving some inequalities algebraically. To start with, we've got some very easy ones. This one here, 2x is greater than 12, so we just divide both sides by 2 and we get x is greater than 6. Simple as that. This one, again, it's a balanced method. I'll take the 1 across and take it away. So I end up with 2x is less than 16. Divide through by 2, I get x is less than 8. Simple as that. Again, just applying the same methods we used on the balanced method. So I've done some of the harder ones down here for you. Done E for you. First thing you need to do is to multiply the bracket to get you 3x plus 6. Because I've done 3 times x, give me 3x. 3 times minus 2, give me minus 6. And that is less than 36. So the next line, when I add 6 to both sides, then I'm going to get 6 added on to 36. 36, add 6, 42. Divide through by 3, 42 divided by 3. So I get x is less than 42 divided by 3, or we can just write x is less than 14. Starting with this one for h. Again, need to multiply out the bracket. 5 times 1 gives me 5. 5 times 3x gives me 15x. First thing I'm going to do is to get rid of the 5 from that side. So when I take it over here, I'm going to take away 5 from both sides to get rid of it from there. Take away 5 from that side. It will give me minus 10 is less than 15x. So when I've got the minus 10 is less than 15x, I've got to divide through by 15. So 15 comes over to the other side and does the opposite. Minus 10 divided by 15. That will give me minus 2/3. So we've got x is greater than minus 2/3. Sometimes it's more tidy to write it that way so you can read it more easily. X is greater than, still got the same direction, the big end with the x, the little end with a number, x is greater than minus 2/3, or I know many of you prefer decimals, minus 0.6666. You could be clever and put dots over it to show it's recurring. So these, a little bit more tricky, these are the sandwich ones I mentioned. Simply just solve each side individually. So you can solve that side and then solve this side. I've tried to be clever and set it out and do them simultaneously, as the Americans would say. So I've worked through P for you. Essentially, I've split it, as I mentioned in the first part, split it into this inequality there and this inequality there. I'm going to do them, as I say, simultaneously, just like the Americans would. I won't do them simultaneously, that's far too British. Take away 10 from both sides. So if I take away 10 from here, it will get rid of that. But I've got to take it off here to get minus 15. If I take away 10 from there, it's going to get rid of that. And this will become minus 12. So there's your next line. I've now got 3x. For this one is less than minus 12. For this one, 3x is greater than minus 15. And both of these you can divide through by 3 because that's the opposite of times by 3. So you end up with x is greater than minus 15 divided by 3 and x is less than minus 12 divided by 3. Then that gives you the minus 5 is greater than x and x is less than minus 4. And then you put it back together, you get a nice full sandwich solution there. It's a much tidier way to write the answer and how you'd expect to do it. That particular one gives you quite a narrow range. So I'm going to take you to the warning I gave you about the one time when inequalities don't behave exactly as an equation or an equality would. And it's when we've got what we call a negative coefficient. So minus 3, it's a negative number in front of the x, minus 3x, a negative coefficient. If I solve this normally, I would first of all get rid of the 1 from both sides. So I'd end up with 9 is greater than or equal to minus 3x. I can divide through by 3 to end up with 3 is greater than or equal to minus x. That all works absolutely fine. So when I start trying to play around with this negative with the x, then things go a little bit different. I'm going to show you on this example what happens. I can reason through from this when I've got that 3 is bigger than or equal to minus x. Remember in double negatives, if x is minus 3, that would be minus minus 3. So that will give me 3 is bigger than or equal to 3. So that works. That one there. Now, for it to be bigger, I'm going to need this answer over on this side to be now less than 3. To be less than 3, it's going to have to be minus 2. Because minus minus 2 will be plus 2, and that is less than 3. Less than because I've got the smaller there. So minus 2 works. If I put in minus 1, I get minus minus 1, and 3 is greater than 1. So that does work. So you can see the answers are going that way. If I put in minus 4 in there, I get minus minus 4, and that will actually be plus 4. And that is not less than 3. So plus 4 doesn't work. Now, if I'd have tried to be clever and get rid of that negative sign and divide it through by minus 1 to change it to minus 3 is greater or equal to x, which in normal equations you would to make it prettier. Now when I look at this, to make this actually work, I get that minus 3 still works because minus 3 is equal to minus 3, so that still works. But I now need to put in minus 4 because for this to be bigger than that, minus 3 is bigger than minus 4, because -4 is colder. We're going down in temperature, so that is bigger. And it's bigger, -3 is bigger than -5. If I was choosing -2, well, -3 bigger than -2? No, it isn't. -2 is bigger than that. If you think about a temperature gauge, -2 is up here, -3 is lower, -4 is lower still. So this, by dividing through by a negative, has been flipped. So if I'm going to divide through by a negative on an inequality, then you need to make sure you flip the sign. So this greater than or equal to has changed to a less than or equal to. If I reason through what numbers work for this, you'll see the same numbers I had at the top will work down here at the bottom. So you have two solutions to this sort of problem, which hopefully won't come up. But if it does, you need to be ready for it. You can either remember to flip that inequality sign because you divided through by a negative, or you can leave it in the original format there and actually just solve it by working on the negatives. Okay, that's the one time they are different to equalities. And that's the one thing we need to account for. Other than that, it's just applying all the solutions and methods we've used before. That, thankfully, is the end of chapter 10, because chapter 10 is a massive chapter, introduces lots of ideas, lots of skills for equations and algebra, which is one of the big differences between the higher and the foundation course. But if you can do this stuff, you will do really well. So practice, 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 and have a great summer doing some wonderful mathematics. Okay, take care. Farewell.